Hi guys, welcome to mathematics. In this video we want to solve for x in x raised to power 6 equals 9 raised to power x. My great friend, can you find the value of x that balances these powers? So you can actually do before you watch, but let's solve it together. Let's see solution. I have x raised to power 6 equals 9 raised to power x. So from here, we can have this becomes x squared raised to power 3. From the product power law, when number which is equal to a certain power is again raised to another power, the powers are multiplied. So we have this equals 3 raised to power 2 multiplied by x. Right? So let's recall that if you have p raised to power m raised to power n, this is equals as 11 p raised to power n raised to power m. So we'll have this becomes 3 raised to x raised to power 3 square equals 3 raised to power x square. All right, so we can transfer this to this side. So we have x raised to power 3 square minus 3 raised to power x square equals 0. Right? So here, let's recall the difference of two squares that says if you have a square minus b square equals a plus b multiplied by a minus b. So applying this to this, we will have x raised to power 3 plus 3 raised to power x multiplied by x raised to power 3 minus 3 raised to power x equals 0. Right? So which implies that this equals 0 and this equals 0. So we have x raised to power 3 plus 3 raised to power x equals 0, or we have x raised to power 3 minus 3 raised to power x equals 0. So let's say this is what is case 1. Let's have this to be case 1 and this to be what? Case 2. So then we solve each of them to obtain our solution. Let's say case 1. We have x raised to power 3 minus 3 raised to power x equals 0. So let's transfer this to the other side. So we have x raised to power 3 equals 3 raised to power x. Right? So here, to obtain our x, we introduce ln to both sides. So we have ln x raised to power 3 equals ln 3 raised to power x. So this becomes 3 ln x equals x ln 3. So if you divide both sides by 3 here, 3, this will cancel out this, so we have ln x equals x ln 3 divided by 3. All right, again, if you divide through both sides by x, we will have ln x divided by x equals x ln 3 divided by 3 and divided by x, which becomes ln x divided by x equals x ln 3 divided by 3 times 1 divided by x. Right? So we have ln x divided by x equals x ln 3 divided by 3x. All right. So looking at this, this we cancel out this, right? So we have ln x divided by x equals ln 3 divided by 3, right? So now from here, either you consider the numerator or denominator. If you compare the numerator, we have ln here, we have ln here. So we have x here, we have 3 here. So we are going to say x equals 3. And if you are going to consider the denominator, we have x equals 3. So therefore we have x equals 3, right? So this is our first solution. So you can say our x1. So we have case 2. Our case 2 says x raised to the power 3 plus 3 raised to the power x equals 0, right? Also, let's transfer this to the other side. So we have x raised to the power 3 equals minus 3 raised to the power x, right? So we have x raised to the power 3 equals, you know that minus 1 equals I square, right? I square equals minus 1 from complex number multiplied by 3, and we have raised to the power x here, right? So here also we introduce ln to both sides. So we have ln x equals ln I square times 3 raised to the power x, right? So okay, we have raised to the power 3 here. So this will become 3 ln x, right, equals, this also will come forward, so we have x ln I square times 3. So we can divide both sides by 3 here, this by 3, this will cancel out this, so we have ln x equals x ln I square times 3 divided by 3. Also here we can divide by x. If we divide by x, this will also become like this, so x will cancel x, so we'll have ln x divided by x equals ln 3 times I square divided by 3. But let's recall that if we have exponential ln x raised to the power minus 1, this is equals x raised to the power minus 1. So because this exponential, we can do this ln, so we can have our x replaced with this, so that this will become ln x times, so this becomes x raised to the power minus 1 equals ln 3I square divided by 3. So let's replace x raised to the power minus 1 with exponential ln x raised to the power minus 1. So we have ln x times exponential ln x raised to the power minus 1 equals ln 3I square divided by 3. All right, so from here we are going to apply Lampard function, but before we do, we have to do something. So make sure that this place, the base and the power here are the same. So this will become ln x, right, multiply by exponential minus ln x equals ln 3I square divided by 3. So let's multiply throughout by minus 1. So we have minus ln x times exponential minus ln x equals ln 30i squared divided by 3. So we have this base and this power the same now, so it is for us to apply the Olympiad function. But remember, Olympiad function, if you have the Olympiad function of a exponential a, this is equals to a. So let's apply exponential to both sides of this. So we have the Olympiad function of minus ln x times exponential minus ln x equals the Olympiad function of ln 30i squared divided by 3. So I'm very strong there. So let's, okay, we see that, okay, here we multiply both sides by minus 1, so we have minus here, right? So now we have minus ln x equals the Olympiad function of minus ln 30i squared divided by 3. Right, so let's take this minus back to its power. So we have ln x raised to the power minus 1 equals the Olympiad function of minus ln 30i squared divided by 3. Right, so here we can actually introduce exponential to both sides to cancel this ln. So introduce exponential, we have exponential ln x raised to the power minus 1 equals exponential the Olympiad function of minus ln 30i squared, right, divided by 3. So you know we'll have this cancelling this, so we will have x raised to the power minus 1 equals the exponential of minus ln 30i squared divided by 3, right? This becomes 1 divided by x equals 1 divided by, so 1 divided by exponential the Olympiad function of minus ln 30i squared divided by 3. So taking the reciprocal of both sides, we will have x to be equal 1 divided by exponential Olympiad function of minus ln 30i squared divided by 3. So guys, you can leave your answer like this, and if you like, you can leave it like this. So having x equals minus 3 the Olympiad function of minus ln 30i squared divided by ln 30i squared. Thank you for watching, guys. I hope you enjoyed this video. Kindly like and leave a comment, and don't forget to share with a friend and network. Do well to also subscribe to my channel to stay updated on my next video. Bye.